Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from June 2020 theory. In the last video, we have already discussed question 1 and question 2, and today's lesson we will start from third question. And today's lesson we will talk about question 3 and question 4. As always we do, we will discuss these questions in detail so you can improve your understanding of practical skills in physics, and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 3 says, a student investigated the diffraction of electrons using an electron beam tube as shown in the figure. The potential difference V accelerates electrons from the hard filament towards the thin graphite foil. The electrons diffract as they pass through the foil, producing a ring pattern on the curved fluorescent screen as shown below. For part A, the student used vernier calipers to measure the diameters of the rings on the curved screen. Give 2 reasons why vernier calipers are more appropriate for these measurements than a transparent meter rule. I hope the first thing you can simply say, vernier calipers, they are more precise because they have higher precision. So first thing we can say, vernier calipers, they have higher precision because the precision of vernier caliper is 0.1 mm, and precision of meter rule, so we can say precision of meter rule is 1 mm. So it means that vernier calipers, they are more precise. If higher precision, it means lower uncertainty. So we can say lower uncertainty. So we can say lower uncertainty. And the second reason is that this surface is curved. So you need to understand this surface is curved, and these rings, they are formed on the curved surface. So with meter rule, it's not easy to measure the diameter of the rings. So vernier caliper is more suitable or more appropriate in this case because the tips of the vernier caliper we can simply align with the rings and we can find the diameter. So you can talk about these 2 points, very practical points. So first of all, you need to understand the question, and then knowledge. You need to answer the question. Is not difficult if it is clear to you what exactly question is asking you and you have the clear picture of the question in your mind. This practical exam is quite easy. Most of the time students don't understand question carefully, or the basic concepts are not very clear, or simply they don't understand how to apply concepts in unseen situations, and that is not good. Physics is like a screwdriver. I mean, you have this screwdriver, more you use this one, means more concepts in physics you use, better you know how to use this one. So practice is very important, and always try to develop your concepts, not just try to memorize something without opening your eyes. So your eyes should be open, your mind should be open. Physics is not something you need to memorize. Physics is something you need to understand. When you start understanding physics, you start loving physics. If you don't love physics, it means you don't understand physics. It's like this, I don't know someone, so how I can love someone? When I know someone more and that person is according to my expectations, then I will love that person more. So physics is in same way. If you don't understand physics, of course it will be very hard for you to answer the question, and always you will stop and you will complain physics is difficult. Physics is based on understanding. When you really understand concepts in physics, you will have a lot of fun to apply those concepts in different situations, and you will come up with right answers. If you still don't love physics, it means you don't know physics. So try to understand physics. I hope you understand this question. So let's move on to next one. So how we can write on the answer. So this is how you can write on your answer. You can talk about these 2 points in your answer. If you have written the first point, you will get 1 mark, and if you have written the second point, you will get 2 marks. Second part says describe how the student should measure the diameter of a ring as accurately as possible. So how we can measure diameter accurately? This is very common question. In many past papers they will ask you to measure diameter. So how we can measure diameter accurately? We have to measure diameter at different positions. So we can simply say different positions, or you can say at different orientations, and then just simply calculate mean. So these 2 points you have to write down, calculate mean. And this question has 2 marks. If you write on these 2 points, you will get 2 marks. This is very common question. Whenever in the exam they ask you to find diameter, you can mention these 2 points. So for the answer of this question, we can write on measure diameter in different orientations, repeat the measurements, and calculate a mean value. Part B says the student used the diameter of the rings to determine the wavelength of the electrons. He repeated this for 2 more values of potential difference. The student also determined the value of a constant A using the formula as given here. The results are shown in the table below. For part A1, determine the mean value of A in meter square volts. So simply we have the values of A. So these values of A are given to us. We need to find the mean value of A. So simply we can say we have to find out A mean. So simply we have to add these values first of all, and then we need to divide by the number of readings. We have 3. So our final answer in this case has to be 1.22 times 10 to minus 18. So this is meter square volts, because this is multiplied by 10 to minus 18. So this factor is here. So very important, this factor is given here. And also one thing more, you have to be careful, as these values, these measurements, they have 3 SF. So they have 3 SF. So your final answer also should have 3 SF. So this is our final answer. Second part says determine the percentage uncertainty in the mean value of A, and we have repeated measurements for A. So in order to calculate percentage uncertainty, simply we need to take the half range. So this is our main formula, half range divided by the mean value, divided by mean value of A, and we need to multiply this one by 100. We have already calculated mean value, that was equal to 1.22 times 10 to minus 18. So this is mean value. Now simply we need to calculate half range, and we need to multiply this one by 100, and we will get final percentage uncertainty in A. In order to calculate half range in this case is equal to uncertainty. So half range is equal to absolute uncertainty. We have to take the maximum value in the given data minus the minimum value, and we need to divide by 2. So maximum value we have this one. So this is the maximum value, 1.32 minus, and this is the minimum in this data, 1.11, but we need to multiply this one with the factor 10 to minus 18, and we need to divide this by 2. And if we solve this one, we will get 0.105 times 10 to minus 18. Now simply we have to plug in this value here, 0.105 times 10 to minus 18, and if we simplify this one, we will get our final answer, that is 8.6%. So this is how you need to calculate. So when you need to calculate percentage uncertainty for repeated data, you have to use this formula, and this is how you can calculate uncertainty for repeated measurements. Third part says a different student repeated the investigation using 6 values of V. She plotted a graph of V against 1 over lambda square and determined the constant A from the gradient. Give 2 reasons why this is a better method to determine a value for A. So first of all, we need to understand, in the last part it was given to us, we have A that is equal to lambda square times V. Now if we rearrange this one, we can say we have V is equal to A times 1 over lambda square. Now if we sketch a graph between V and 1 over lambda square, we can compare this one with straight line equation. So A is represented by the gradient. Now we can talk about two reasons why sketching the graph is a better method. So the first thing we can say, we have more sets of data. We have more sets of data. And the second, we can talk about the graph. So this is our graph. Very important point, beautiful point. Listen carefully. So here we have V on y-axis and we have 1 over lambda square. This is on x-axis. Now we can also imagine that this is our best fit line. And we can also just assume some data. Imagine that the points are like this. So these are the points. These are the points. So there are 6 points. So simply we can say these are the 6 points. And this line is the best fit line. These points, as these points are scattered, they are away from each other. They are telling us there is random error. So these points are telling us there is a random error in the measurements. By sketching this best fit line, we have minimized the random error. Beautiful point. So we have minimized random error. So that's the reason we draw the best fit line. And the second thing we can say is, as gradient is representing A, so we no need to worry about y-intercept. It simply means that if we sketch the graph, we can ignore systematic error, because systematic error we can see from the graph by y-intercept, or we can see by x-intercept. Means if there is a systematic error in the data, there will be y-intercept or there will be x-intercept. So if we sketch the graph and we simply calculate gradient, so it means we can ignore systematic error. So let me write on here. So this means there is systematic error. So simply we can say there is systematic error. So if we draw the best fit line and we calculate the gradient of this best fit line, it simply means that we can ignore. We are ignoring systematic error. Means we can ignore systematic error. So these are the benefits of sketching the graph. So that's the reason always when we do experiment, we sketch the graph, because when we sketch the graph, we can draw the best fit line, we can minimize random error, and also we can ignore systematic error. We no need to worry about systematic error. If we just simply calculate the mean value, in the mean value there will be systematic error, also there will be random error. But by sketching the graph and by drawing the best fit line, we can minimize random error and also we can ignore systematic error. A beautiful point. You need to understand why always we draw the best fit line. So for this question we have to mention only 2 points. Let me show you the answer, how you can write down your answer. These are the points you can mention in your answer. So simply we can say, in this case, more pairs of values are used. Means we have 6 sets of values now. Before there were only 3 sets of values. Adding a line of best fit acts as an averaging method. You can also say adding a line of best fit can identify anomalous values as well. Anomalous, if one point is far away from the best fit line, it means that point is the anomalous point, and the gradient will ignore any systematic error. So these points we can mention in our answer. Practical question. So try to understand, why do we need to sketch the best fit line? Because the best fit line minimizes the random error, and also if we calculate gradient, we can simply ignore systematic error. Part C says the value of A can also be calculated using the following formula. H is the Planck's constant, E is the electron charge, and Me is the electron mass. Calculate the value of H in joules seconds, where A is equal to 1.46 times 10 to minus 18 meter square volts. So we need to calculate H, so we can rearrange this formula. So we can write down, this is 2 E M E times A and the square root of this one. Now simply we can plug in values. E is the charge on electron, that is 1.6, times 10 to minus 19, and the mass of electron is 9.11 times 10 to minus 31, and we have A, that is equal to 1.46 times 10 to minus 18. So simply we need to take square root of this one. If we solve, we will get our final answer 6.52 times 10 to minus 34 joules seconds. As given data means this constant we can also write on 1.60. This is the charge on single electron. As given data has 3 SF. So in the final answer we also need to use 3 SF. So it has to be up to 3 SF. Second part says the percentage uncertainty in the calculated value of H is 6%. Comment on the accuracy of your calculated value of H. So we have percentage uncertainty that is equal to 6%. If calculated value of H is correct, so the percentage difference has to be lower than percentage uncertainty. So simply, first of all, we have to calculate percentage difference. Percentage difference. We have accepted value, or we can say the standard value of Planck's constant, that is 6.63 times 10 to minus 34, and our calculated value is 6.52 times 10 to minus 34, and we need to divide by the accepted value, mean the standard value of H. We are comparing with standard value, very important one, comparing with standard value. So we have to divide by the standard value, that is 6.63 times 10 to minus 34. So we are finding the percentage difference with standard value. So you have to divide by standard value, and you have to multiply this one by 100. Now if we simply solve this one, in this case we will get percentage difference is 1.7%. So we can simply write down as percentage difference. As percentage difference is lower than percentage uncertainty, that is equal to 6%, so calculated value is correct. So simply we can say, so calculated value of Planck's constant H is correct, or we can say is accurate. So this is how you need to answer. So this is how you need to answer. But if percentage difference is greater than percentage uncertainty, it means is inaccurate. So this is our criteria. I hope this one is clear. Question 4 says a student investigated the extension of an elastic cord. She hung a 1.2 kg mass from the elastic cord as shown in the figure. For part A, identify a health and safety issue and how we can protect. So first of all, if you simply look at this mass, this is a heavy mass, 1.2 kg mass. If it fall down, it may injure the feet. So how we can protect? We can protect by wearing safety shoes. So we can say mass may fall. In this case we can say mass may fall and injure feet so wear safety. So we can say, so wear safety shoes. Safety shoes, or you can say safety boots. So this is one you can write down. If you write down these 2 points, you will get 2 marks. We can also write down this elastic cord may snap. Elastic cord may snap. So we can say, so wear safety goggles. So wear safety goggles. So we can also talk about this part as well. So wear safety goggles. So this is how we can answer. Part B says the student varied the distance between the two stands to vary the angle theta. She measured angle using a protractor. For each value of theta, she measured the corresponding length x with a meter rule. Identify 2 sources of uncertainty with this method. So first of all, in this case we are using meter rule. So whenever we use meter rule, there is always uncertainty due to parallax error. So this is one point we can say. And the second point we can say is when she will measure this angle, and if she touch the string, so maybe she will apply some force on the string. So the second point, some force on string while measuring. So while measuring angle and x, measuring theta and x. So that is also source of uncertainty. So like this you need to understand. Imagine that this is a real practical. You are doing this experiment in the lab. So when you will measure angle, you will apply some force on the string. Or when you measure x, you apply some force on the string. So that will cause uncertainty, means your value of measurements will not be that accurate. So simply we can mention these 2 points. So we can say, first of all, when we're using meter rule, there is Perex error. Applying an additional force to the cord while measuring theta and x will cause uncertainty. So the best way to answer this type of problems is, when you see the figure, imagine that you are doing this experiment by yourself in real situation. Then you will be able to find out the reasons or the sources of uncertainties. Second part says, suggest a modification to reduce the effect of one of these sources of uncertainty. So first of all, we have talked about Perex error. So how we can minimize Perex error? Minimize Perex error by viewing perpendicular. So we can say by viewing measurement perpendicular to meter rule, perpendicular to rule. So this is one way. Second, we have discussed about applying force in the previous part. So we can avoid applying force by avoiding, we can say, by avoiding, or we can say not touching. So we can say by not touching string with meter rule and protractor. So this is how we can modify protractor. And these 2 points you can mention, but this question has only 1 mark, so you have to mention only 1 point. So we can say viewing measurement perpendicular to meter rule and ensure the protractor does not touch the cord. Part C says the student determine the extension delta x of the elastic cord for each value of theta. The relationship between theta and delta x is given by this equation. M is the mass hung from the elastic cord and K is the stiffness of the elastic material. Explain why a graph of cosine theta against 1 over delta x can be used to determine a value for G. And so it simply means that if we sketch a graph between cosine of theta by 2 and 1 over delta x, so the unit of this one has to be per meter. But what is the unit of cosine of theta by 2? I hope you will say it has no unit. It has no unit, because cosine of theta, sine of theta, tangent of theta, they are the ratio between 2 same quantities. So cosine of theta, sine of theta, tangent of theta, they have no units. So this is one thing we need to understand. Now simply if you look at this equation, we can rewrite this one. We can say cosine of theta by 2, this is equal to mg divided by k times we have 1 over delta x. Now if we compare this one with straight line equation, means y is equal to mx. So in this case, this is the gradient. So in this case we can say gradient is equal to mg divided by k. So we have to determine g from here. So we can say g will be equal to gradient times k divided by m. So this is what we need to write down for the answer of this question. A typical question, simply you need to understand how to rearrange this equation, and then you need to compare with straight line equation. Second part says the student recorded the following data. Plot a graph of cosine theta by 2 on the y-axis against 1 over delta x on the x-axis on the grid opposite. Use the additional column of the table for your processed data. So we need to sketch graph between cosine theta by 2 and 1 over delta x. So in this column we have to write down 1 over delta x, and the unit is per meter. So simply we have delta x here, so we can say 1 over delta x, this will be equal to 1 over 0.165, and if we simply solve this one, we will get 6.06 per meter, and this one we have to write down here 6.06. But we have to be careful with number of SF. This has 3 SF, so this also should have 3 SF, because raw data has 3 SF, so the processed data or calculated data, it also should have 3 SF. And same we can repeat for remaining values of delta x. So if we do this carefully, we will get these values. So we will get these values of 1 over delta x. So you have to be careful with number of SF. So all of them, they should have 3 SF, because here we have 3 SF. Now we need to sketch cosine theta by 2 on y-axis. So this quantity has to be on y-axis and this quantity has to be on x-axis. So first of all, we can label these axes. So we can say 1 over delta x, unit of this one is per meter. So we have to write on the unit as well. And cosine of theta by 2, it has no unit. So we can say cosine of theta by 2, it has no units. So first of all, we can label x-axis and y-axis. Next thing, we need to choose a sensible scale. To choose scale, we can take the maximum value 0.938 minus the minimum 0.891 divided by number of small square. We have 12 number of small squares. We divide by this one, so we will get 0.0039. We can round off this one to 0.005. We can also round off this one to 0.004, but 0.005 is a better, so we can round off this one to this to keep our calculations simpler. And for x-axis, we can repeat the same process. So here we have the maximum value 6.06 minus minimum 5.46 divided by number of small square. We have 8 on x-axis. This is standard graph, so if we solve this one, we will get 0.075, but this is number is not easy to plot, so we can take 0.1. So one big square, it means one big square on y-axis is equal to 0.005, and one big square on x-axis is equal to 0.1. Now simply we can label this one, and then we can simply plot the points, and then we can draw the line. So let me show you how you can do this. So this is how you can sketch the graph. So in this case, you can see what we have done. We have labeled x-axis and y-axis with units. So let me clean this one as well. So this one we can also clean. So you can see we have quantity here, but this quantity has no unit. This quantity has unit, so we have to write down the unit. One big square on y-axis is equal to 0.005. You can see the difference between these two. So this is 0.005. On x-axis we have 0.1. 5.40, we have 5.50. So this big square is equal to 0.1. Now simply these numbers we have, So we have to simply plot, then we need to draw the best fit line, and best fit line simply means that it fit all the points, mean the same number of points above the line, same number of points below the line, and also the distance from the line of the points is almost the same. So if you look at this graph, you can see this is lying on the line, so this is best fit. This point, if you look at this point, this is below the line, and this point is above the line, and this point is just passing through this one, almost passing through this. This is little bit lower and this is little bit higher. So you can see this line fit all these points. So this is how you need to draw the best fit line, means the line should fit all the points, mean equally distributed above and below the line. So the vertical distance is also very important. For example, if you see one point here, for example, and one point here, so this is not the best fit line because this vertical distance from the line is much greater than this distance. So this will not be the best fit line if we have points like this, and this line is the best fit line. Now for example, if I have these points and if I have drawn the line like this somewhere, like this line is shallow because you see a lot of points above the line, so this line is shallower. So we will say this line is shallower, so this is not best fit line because you see a lot of points above the line. And if we draw the line like this, let's say we have drawn the line like this one, so in this case you can see a lot of points, they are below the line, so this line is steeper, so this is also not best fit line. So this is not best fit line, this is also not best fit line. Best fit line means that it fits all the points, means not too steep, not too shallow, so it fit all the points. So this is how you can draw the best fit line. Third part says determine the gradient of the graph. So we have to choose 2 points on this line. So let's say we take one point here at this point. Let me change the color, so we can take one point here and we can take one point here. These 2 points has to be away from each other, or simply we can say the distance between these 2 points has to be more than half of the length of this line. So it's very important point. Don't take these 2 points close to each other. Now simply we can draw the triangle. So let me show you how you can draw the triangle. So this is how we can draw this triangle, and now we can calculate the gradient. So gradient in this case simply will be equal to delta y by delta x. So delta y, so we have here 0.935 minus we have here 0.895 divided by we have x 6.03 minus we have 5.52, and if we solve this one we will get 0.078. So this is how we can calculate gradient. Question 4 says determine a value for g from the gradient of the graph. And we have already discussed in the previous part that g is equal to gradient times k divided by m. Value of gradient we have calculated, that was equal to 0.078, and k is given to us, that is 145, and value of m is given, that is equal to 1.20. Now if we simply calculate this one, we will get g is equal to 9.43, and the unit of g is meters per second per second. So this is our final answer. So simply we can write on here 9.43 meters per second per second. So this is the answer. That's all for today's video. I hope this video was helpful. If this video was helpful, please like and subscribe, and also for extra help and more resources you can join Patreon.